Hi and welcome to R001 downloading OpenStreetMap data directly into R. My name is Adrian Cidre and with this video we are starting a new R series. In this particular R tip you will learn how to download data from OpenStreetMaps directly into R. You will learn how to download this data from any place in the world. And here I have a couple of notes. We will use the osmdata package, which works for small to medium sized datasets. And for bigger datasets, you should have a look at the OSM extract package. So we will start loading the packages that we need, which are the Gisco R, MapView, osmdata, and the SF package. So the first function that we will use is the available features, which is part of the OSM data package, and I will make this smaller. So here you have the different features that are available in this OSM data. So these are different datasets that you can have a look at, but you can also open the help with F1 of this function and you will see this reference. So if you open it, you will see this website where you have the different features by different categories. So let's say that I want to see which are available in water, so I can go here and we see that we have these features of water and then they have different values. So for water we have rivers and we have a short description and also an image. So you can have a look at the different ones that you have in this OpenStreetMap API. So now we have also the available tags function where we can introduce one of the features that we saw before here. So in this case, I'm introducing sauna. And when we use available tags, we will see also the different values that we have for that particular feature. I can go here and use Ctrl F to find sauna, and you can see that we have yes and no. And we see that this particular feature will describe whether a sauna is available. And we can also check for water, for instance, and here we will see that we have different values for the same key. We have, for instance, the basin, we have here the river that we saw before in the website, and so on. So now we will see the first step for building an API query to retrieve the data, which is getting the bounding box of the study area. Here I will show you three different options. We can use one polygon. In this case, I got the polygon of the Czech Republic, so this is the country polygon. And if we use the stvbox function from the SF package, we will get this vector of 4 coordinates. And note that for the OSM data package, the order needs to be xmin, ymin, xmax, and ymax. So in this case, we see that with this function, we get the correct order. Another option is to use known coordinates, and we can introduce them inside a vector, but we need to take care of the order because it has to be exactly this order that we have here. And the last option, which is very convenient, is to use a name inside the getBB function, which is inside the OSM data package. And this function uses the nominatim API where we can introduce a name and it will retrieve a bounding box. So if I use getBB for Czechia, you will see that we get this vector with the 4 coordinates, the xmin, the ymin, the xmax, and the ymax. And you will see that this function is very flexible. We can use also Czech Republic instead of Czechia, and you will see that the result is exactly the same. And here we have another example where I'm using the capital Prague. So if I use getBB Prague, we get these coordinates. I can also use Prague, Czechia, and you will see that the coordinates are exactly the same. And I can even write it in Czech, so I can write Praha, Česká republika. And if I execute it, you will see that the result is the same. So very convenient function because it's very flexible. The next step is to build a query. And to build a query, we need to introduce two components. The first component is the bounding box, and we saw how to get it in different ways. And the second one is to introduce the feature and tag. And this is what we saw before in the available features and available tags. So to build an overpass query, we need to use the OPQ function, and inside we can introduce the coordinates of the place. So we can introduce getPB Czechia, and with that we are building a query which is used later by the package inside. This is just a list which has different elements, as you can see here. But one thing that is very convenient is that we don't need to use the getPB function, because we can use directly Czechia instead of getPB Czechia, and the package will know that we want to use that function inside this one. So if we execute this, you will see that the result is exactly the same as if we introduce it like this. Then we need to add the feature, and in this case I'm using the overpass query, and then I'm piping it into the add OSM feature function. And here I'm introducing the key sauna that we saw before, and when we execute this we are still building the query. So now we have all this query, and we added the different elements that are needed for searching for the sauna. And lastly, we have here another example for looking for lakes and reservoirs in Czechia. So I'm building the overpass query for Praha, and here I'm adding an OSM feature where I say the key water, and here I'm introducing also the value, because I don't want all the values of water. I just want the lakes and the reservoirs. And if I print this into the console, we will see this result. And we see the bounding box of Praha here, and we can see the features that we added, which are water, lake, reservoir. And you see that this is in a format that is needed for this particular package. And now the last step is to retrieve the data. And to retrieve the data, we have to introduce the overpass query that we built before inside the osmdata function. And when you use osm data underscore, you will see that you have different formats. You have XC, SF, which is probably the most common, SP, and also XML for metadata. So in this case, I'm retrieving the data in SF format, and I can print it in the console. But you see that this is a list with different elements. We have the bounding box, overpass call, and so on. But here we are mostly interested in the points, because if you remember, we are searching for saunas, and the element sauna is just telling us where the sauna is. So we are interested in the points, and we see that in Czechia we have a total of 628 different points. So we can extract it from this list by using the $sign and the OSM points. So if I print this now in the console, you will see this object which has many fields and many NAs. And we can view this dataset by using the map view function from the map view package. And you will see that actually in Czechia we don't have that many saunas. They are inside the bounding box of Czechia, but they are not inside the country. So if we wanted to analyze the saunas of Czechia, we should calculate the intersection. And finally, we will extract the lakes and reservoirs from the Prague city. So here I'm passing the overpass query that we built before to the OSM data SF function, and I will print it in the console, and you will see that you have the same list. But in this case, we have points, we have lines, and we have polygons. So in this case, since we are analyzing elements that have area, which are the lakes and the reservoirs, we are interested in the points. If we are only interested in the location, we might be more interested maybe in the points, but in this case I think it's better to take the polygons, because sometimes these points you see that they are many more than the polygons, and this is because sometimes the same lake is built from many different points. So here I'm extracting the polygons, which I will print here, and you will see that again you have many different fields without any data, and we can also view it with the map view function. And here you see different polygons. We can zoom in, and you will see that here, if I do this, you will see that they are exactly where we see water elements. I can use the S-reward imagery so we see it better. And last but not least, we can also extract the metadata by using the osm underscore XML. And if I print it, this has an XML format. And we might be interested to export it by using the proper function. And finally, we can see here the whole game because we can use everything just in one piece of code. So first we build the query, we add the OSM feature, and finally we retrieve the data.